Let me show you something real quick. This is the frequency of the power running through this switch. You can see 50 Hz on the display. Hold on, let me keep it steady. 50 Hz. This is the switch for my light bulb. If I turn it off now, my light will go off and I can put it back on. So you see there's power actually going through it. And this is possible through the frequency meter on my auto range multimeter. And this is one of the meters you cannot find on this manual range digital multimeters. You can only get them on this type of meters and other ones that are even more sophisticated than this particular one. So the frequency meter, the way it works is it picks the frequency of the AC current even before it touches anything. That's why I'm able to read the frequency of the power passing through this switch even without opening the switch. As you can see, I'm reading 50 Hz here. And one of the most beautiful thing about this particular frequency meter is it also has a duty cycle meter. Let me explain, but before that, let me show you how the frequency meter works. So I have an extension here plugged to a power. You notice that I'm even using just one probe for the frequency meter. I don't even need the second probe. Just one probe is enough to use the frequency meter. The probe getting close to any power source that is AC, it is already reading the frequency. You can see 50 Hz because the probe is just close to the socket. If I move it away, it will go back to 0. And with this, if I take my system now, my probe is on my system because there's power connected to it. You see, it is sensing some frequency from my system. So this is very handy for people who are into solar systems or building inverter itself. You will notice that in some cases you will install an inverter system. The NEPA will be charging the inverter, but the generator will not be charging the inverter. In most cases, it's because the generator frequency is higher or lower than what the inverter could accept. And you wouldn't know that except you have a frequency meter to check the frequency of the generator. Now, coming to the duty cycle, that one is also very, very important. And this meter also has that. So currently we're on frequency. That's why this is showing Hz. So if I click on this button over here, it moves to percentage. This is the one that measures the duty cycle. And if I put this probe on any of these terminal, you can see the percentage. So it is showing 49% on this terminal. I don't know if this is the live or the neutral terminal. And if I move to the second terminal, it shows 50 point something percent. All right. Sorry, hold on. Let me put it properly. Okay. This is it. 50.0 something anyway. So duty cycle is the waveform of an AC current. Let me show you what I mean. For you to understand what duty cycle means, look at this diagram here. So this is an AC current, alternating current, the way it moves. So we'll have 220 volts, which is the regular voltage we have, and this will also be 220 volts. But the difference between these two is that this is positive and this is negative, right? So what you notice is that the current is alternating on the high side and also on the low side. That is why it is called an alternating current. And the duty cycle is the full complete cycle of this alternating current. So if it is starting from here, so from here to here, let me draw a line, is a complete duty cycle, 100%, right? Then each of the cycle on the high side and on the low side, ideally it's supposed to be 50% to complete the 100%. None of them is supposed to be bigger than the other. If you are having 40% on the high side and 60% on the low side, it will give your appliances issue. That's where the duty cycle comes in. So some inverters, if they are not properly designed, or even some generators that are faulty, their duty cycle would scatter and they will be giving higher percentage either on the high side or on the low side, and that would start affecting your appliance. Sensitive inverters itself won't even accept that kind of power to pass through it or to charge the battery with that kind of power, you understand? So this is where the duty cycle meter comes in. See that when we read the one on the sockets, we got 50%, 49.99%. So it is almost at the middle, just 0.001% different, which is very little. This is why I even like this meter more. It was actually the reason why I got it, because of the frequency and the duty cycle meter. And next I'll be showing you how the temperature meter or the thermometer on the auto range multimeter works.